So this is a company very famous for its visual representation of the data. Okay, so this is a company, Tabloid. So this is like a public company, very interesting. They have tons of stuff to play with. I mean, if you have some time, I encourage you to explore this particular. It's a software company. Basically, it's everything can be put into visual format. It's to help a client to see the pattern. I mean, especially like that's why new generation, Instagram generation, we're becoming more visual rather than verbal, because visual is so intuitive. I don't know personally if it's a good thing or bad thing, because once you get on visual, I mean, seeing is believing, and whatever is presented, not sometimes they're not really just appear to be. So especially in the age of the big data, and then also the fake news, fake data, fake information, misinformation, disinformation, all kinds of stuff. So I mean, you know, the picture, right? People want to see the pictures, and since the pictures are more believable than words, it's a picture worth thousands of words. But we know that nowadays the pictures you can manipulate, you can PS, you can do whatever you want to make the picture looks cool, looks good, but sometimes could be problematic. But again, uh, I want to emphasize that the visual representation of data is extremely important in our field, especially if you sit in the, after you finish your research, gathering your data to the presentation. I mean, you want to make sure that tell a compelling storytelling by graphs, by charts, so that the people can get some sense of what's going on in your data. I mean, and in this is kind of research field, you think that's about numbers. No, they're not about numbers. Actually, they are really about how you can get insights, and then convince the management that insights are useful, and then guiding decision making. And this is something. Now let's shift gear to talk about descriptive statistics. And I think that for those of you who are already taking some stats class, that's really easy. But for those who haven't had a chance to take some statistics class, I encourage you to really to pay attention to some of the terms so that you know what's really going on. And then I want you to kind of know that, okay, for our class, measure the central tendency. Okay, we have three different kind of term to describe a central tendency. Basically, when we talk about a group of data points, okay, data, okay, basically say, well, uh, how they gather together, how they kind of how far apart they are from each other, and then and the mean obviously is one of the ways to measure central tendency. Like, okay, we that's most people are very familiar with the mean. Basically, it's like another word called average. Average, and so this is very. But another term is called a median. Okay, median. Median basically talk about the observations. I mean, like a 50% observation for at the 50% point. Okay, so and many times we talk about the median household income rather than mean income, because some small number of people have millions of dollars or sometimes $1 billion. It's going to be outlier if you include those people's annual household income. And then let's say uh, you know rich people, they millions or sometimes hundreds of millions. It's going to skew the data to the high end. So that's not a very good picture. It's going to skew the whole thing. So we tend to use a median as a way to engage the data pattern. And then the third one is called as a mode, the value that occurs most frequently. Basically, like so. You remember the previous example. We have the mode, like movie attending movie theater, kind of for the yes or no. I mean, the mode. What's a mode? It's a one, because 450 people, 449 people say yes to in the last year they attended movie theater to. So this is a mode. Mode is most frequent variable. And then they'll have a second part called a measure of dispersion. Okay, this is the part that kind of like we look at the how widely spread the data from each other. I mean, if you have like a very big range, for example, maximum and a minimum, and then we want to see how far apart they from each other. So then we have a range. Think about the income, right? Uh, uh, annual household income could be some people like a couple of thousand all the way up to millions, or sometimes even hundreds of millions, for billionaires. So that's totally different. So we talk about, we have three different terms to describe the dispersion. The first called variance. Variance, okay. Variance is something that the definition is very, very straightforward, like sums of square deviation from the mean, right? Sum of square deviation from the mean divided by number of observation minus one. Okay, square deviation. Okay, square deviation. Basically, it is a way, say, from the mean, in the sense that they try to capture the variance in the sense that the how far apart from the mean value for each different value, and then they capture it, and then they square them. Because why do we square them? Because if you just don't square them, it's like the positive and negative will cancel each other out. So we want to square them and then divide it by observation minus one. Now, why is it divided by number of observation minus one? Minus one because this is an adjustment by statisticians. Statisticians think that to adjust for some kind of potential bias in the process. Okay, so this is a standard variance. Variance is something very interesting. So I don't want you to be worried about how to calculate the variance, because software, you can do it very simple and very, very easy. Let me show you after we talk about standard deviation, range, kind of stuff. Standard deviation, range. So three different terms to describe a dispersion. So standard deviation is basically it's a square root of variance. Okay, if you think about that basically it's the standard deviation. We always use standard deviation as kind of way to understand how far apart from the average, basically. Okay, so this is something that we use a lot. Let's say, for example, if you are two standard deviation above, and then we're talking about your, let's say you take SAT examination, okay, SAT. So SAT, if you use like two standard deviation, then well you are very high, because you are only you are 95 percentile, basically. Like, okay, so it's very high, actually. So it's you're way above the average. Now, if you say one standard deviation, when we talk about that, you are above 68% of people. So that kind of the idea. So this is so I think it's a standard deviation is a good way to measure the relative ranking of scores, relative position of a certain data patterns, that kind of thing. So let's look at some of the things that we talk about in terms of the how to getting those numbers from the software. Let me go back to the software, like SPS I mentioned earlier. We have this thing here already. So let's say, how do we get those standard deviation, mean, that kind of stuff? So okay, let's go back to the tabs. Okay, we have analyze, right? We have file, edit, view, data, transform, analyze. Let's analyze. Okay, and then we click on the descriptive statistics, and then we click on the descriptive. Okay, descriptive. But remember, we have something called cross tabulate. I want you to explore yourself, in the future. Okay, so descriptive, and then we just want to look at the exact variable, say importance variable, indicate that. Let's go to click on that. Go one, and then on the options, move this question to this box, and then on option part, it's by default it's checked on the mean, standard deviation, and then minimum, maximum, variance, range, standard error of the mean, and then the kurtosis, skewness. So those are stuff. Let's say just talk about this part. We're gonna skip this kurtosis and skewness stuff. Click OK, and then we say click OK. We get this stuff, right? So we get, it's very simple, right? Okay, we have 44, 48 responses. The range is 3. Obviously, it's 1 to 4. 1 the minimum, 4 is maximum. The mean is 2.25. Okay, right? Standard deviation is 0.803, and then uh, 0.645 is the variance. Now, if you do some math, if you figure out the standard deviation is the square root of variance. 0.645 square root is about 0.803. Okay, so that's an example of getting the statistical numbers from the software. So that's why nowadays you don't have to worry too much about understanding, just do the manual calculation how to figure out those numbers, because software makes things much easier nowadays. And now let's look at this descriptive statistic, right? So all those numbers you can get them from the software, so it's pretty straightforward. Okay. Now, as you can see, descriptive statistics kind of, if you take stats class, your stats professor might ask you to do some manual calculation. But I think for our field, if you know exactly what they mean, and then you can have statistics package to do it for you. Okay, so we'll kind of conclude our chapter on lecture on chapter 15, data analysis. And to summarize, I mean, we pretty much accomplished the four learning objectives, right? We understand it's a five-step process, and then we understand the meaning and the process of each different step, and then also we kind of look at especially the data analysis part. We have two different types of data analysis for descriptives and statistics, and among descriptives we talk about the just one way table, frequency table, and then also we cover in detail about the cross tabulations, which is very important in our field. And so I hope that you guys have opportunity to just watch it over again, and just repeat if you want to. And if you have any more questions, feel free to contact me. And then I'll see you back when my return. We will continue our discussion about the communicating research results in the last week of class. Thank you.